Yes, sir.
Okay. So a very good evening to all the candidates who are joining us, who are joining in still on this very Sunday evening for this live interactive session, what we are conducting today on the MLOps. Most of you must have heard of MLOps. So it's what we will be doing in that session. So you all must have heard the jargons around data science and AI, which is booming like anything. And there are certain current changes that we have also faced, the industry has started facing. One of the major challenge currently, what the most of the industries and the practitioners of data science, they are facing is the end-to-end life cycle management of your ML models and the AI models. So now, in order to cope up with that challenge, in order to overcome these challenge, one of the options that could be MLOps. So, which is a set of principles in which that data science or practitioners can adapt to overcome these challenges that that I just quickly discussed with you. So today on this live interactive session, rather me talking, we have the expert with us, Mr. Nabil Mehdi, and he's a senior data scientist at EquiSite. A very warm welcome to you, Nabil, on this live interactive session on this Sunday evening, and all the data science enthusiasts who are still joining for this session. And I would suggest all of you guys who are joining in, so try not to be selfish, right? So you can share that link among your peers and friends so that more and more individuals will get the benefit out of it. A quick brief about Mr. Nabil's profile. So as I already mentioned, he's working as a senior data scientist and computer engineer at EquiSite. So overall, 8+ years of experience he has got into client facing as a senior data scientist and project management roles he's been into at artificial intelligence as a service startup. That company is located at Michigan, that empowers government utilities, public institutions, and industrial plants across the US. Overall, Nabil has got 45+ projects he has worked into, including the academics projects as well. He comes from a research background as well. As I mentioned, he has almost 8+ years of experience in conceptualizing, executing, and delivering full stack solutions that solve complex challenges by leveraging the Lean Sigma philosophy, that background he is coming from, big data analytics, machine learning, and other techniques. So today, without any further ado, may I please request Nabil to take it over from here. And it would be a pleasure for us to hear you, Nabil. So thank you so much, guys, for joining in on this Sunday evening. And I firmly believe that this session will certainly would be a mind-boggling session. At least you will get to know some insights out of that session that we are having today. Over to you, Nabil. Can you hear me?
Thank you, sir, for such an interesting introduction, and also to the entire Aegis team for inviting me, especially Misbah. She reached out to me. So thank you for that. It's a pleasure to be here. Let me share the screen. So it says host disabled participant screen sharing.
Okay, Aditya, I would suggest please give the rights to Nabil so that he can share his screen. And we will have a Q&A session at the end, guys. So if you would have any questions in between, you can please jot down your questions over chat box. So we'll try not to disappoint anyone. We'll try to answer as many questions as we'll be having, though we will have a Q&A sessions at the end. So I believe you can share this screen, Nabil, right?
Yeah, I started sharing, I think.
Yeah, we can see that.
All right. So
yes,
let me begin the slideshow. All right. So are you seeing the entire screen or the text?
Yes, it is very much visible.
Okay.
Very crisp and clear. Yeah.
So, so as Sir mentioned, I am working as a data scientist and software engineer with a AI as a service company located in Michigan. I am here in the last 4 years. So first of all, good evening to everyone joining from India. It's a good morning from me because it's 9 a.m. here, a Sunday morning. So it's a pleasure to be here. And I will be speaking on the topic of MLOps, machine learning lifecycle management, using an open source tool called MLFlow. So let me, there's some notification going on. Let me hide this. Okay. So what I do is basically we work with the government utilities, government plants like water and wastewater treatment plants, where our team builds AI models and deploy them in production. And those models provide them recommendation, the plants and the operators and engineers, some recommendations how to run based upon some insight or recommendation that we have provided to improve productivity. So that is what my background is. And let's begin. So the topic is MLOps. I will try to explain or describe in very basic terms instead of, like sir mentioned about the jargon. I'll try not to go into that direction. So, and you feel free to ask any questions either in between or later in this presentation. So MLOps is a very hot topic in the industry right now, and it is going to be becoming a $5 billion industry according to Deloitte and Gartner Insights by 2025. So there are a lot of job openings right now as MLOps engineering jobs. And it's a great entry point for software engineers and managers who are trying to switch to data science, because MLOps is something that requires a little bit of different skills compared to core machine learning or core data science. It requires more of strategy and management skills, along with, of course, a little bit knowledge about software and data science. So as time passes in the coming years, MLOps will be an essential role in every organization that has AI, that uses AI somewhere. So before I go into MLOps, let's talk a little bit about what machine learning is. So just an overview, what is machine learning? So machine learning, it is a mathematical model. It's a mathematical method, in simple terms, to capture intelligence from raw data in a single file, which we call as model. So let's say you have a data set. So let's say you took a survey of people, and based upon their experience, you ask them what is their salary, and then you took this data set and you used a mathematical algorithm and trained. We call it training. So you trained a model. So model is nothing but a file, right? So that model, which the computer or the mathematical algorithm generated, it learns from that data, just like we learn from something. So it learns from that data. And then what we do is we ask that model some question, and based upon that intelligence, it returns us a response. So on the left side, you can see, for instance, I have, these were the data points, salary versus years of experience. And it was given to a machine learning algorithm. And the algorithm learned that what is the relationship between the salary and the years of experience. And based upon that, this blue line is what it learned. So it's a very simple regression example. It's the most basic example out there for data science and machine learning. So it learned that there's a linear relationship between the years of experience and the salary. So based upon that, if we ask the model, what should be the salary if the person has 15 years of experience? So based upon what the machine learning model learned, it is going to give you a prediction of salary, which is on the right side, you can see. And that number does not exist over here, right? So it's not in the training data set. So this is essentially what machine learning is. So we were successful in replacing this entire training data set with a single file. Let's call it a model. And this model is our digital assistant. So when we ask a question to it, it returns us a response based upon what it learned. And this is also what is known as artificial intelligence, because we developed intelligence in this model. So that's why it's called artificial intelligence. So which brings to the next question, where do I use it? Do I use AI anywhere? So to answer that question, AI is all around us. Every day we are consuming, at least interacting with AI 10 to 15 times, at least. So one example could be when we open our phone with the Face ID, there is an AI model in the backend, which is recognizing your face, and it's opening up the phone. When we log into our Facebook, the recommendations that we see on the homepage feed, the posts that we see, they have been provided to us by a machine learning and AI model at the back end. Similarly, when we open our email, there are some emails in the spam box. So again, that is another model which is running somewhere on the cloud, and that is segregating or it's handpicking the bad emails, the spam emails, and putting it in the spam box. So another example would be the YouTube recommendation. So based upon what we see, what we search for on YouTube, YouTube starts giving us some recommendations of what videos we might like. So again, this is also AI. So as you can see, we interact with AI every day throughout our, throughout the day in different softwares and different programs. And behind every interaction, there is a single or multiple models that have been trained by someone, that have been trained by a data science team to follow a particular task. So I started my career in the food industry. I used to work at a restaurant. So we have talked about ML. Let's talk about MLOps. So to explain MLOps, I'll try to use this example just to simplify things. So I assume everyone knows about McDonald's. Everyone has been to McDonald's some point of time. So that's the reason I like to walk through this example. So let's assume that you like to eat some burger at, let's call it McAloo burger, and you visit McDonald's every day. You like it so much, you visit it every day. You order a burger, you get it in the next, 10, 15 minutes, and you consume it. So the interesting thing about it is that if I visit McDonald's today and then I visit it 2 months later, and if I ordered the same product, if I'm ordering the same McAloo burger, it is going to taste more or less same. So 99% or maybe 100% of the time, its taste will not change. Even the time, so it usually takes 10 to 15 minutes. So it's not like that if today I go to order, I will get the burger in 10 minutes. And after 1 month, if I order, it will be 1 hour. So it's not like that, right? So if I go there, maybe 10 to 15 minutes, if there's a lot of crowd, then it can go to 20, 30 minutes. But if the crowd is same as it was before, again, the serving time will go down to 10, 15 minutes. So this is something interesting to think about. Why is the taste of the burger constantly around the world for the same product similar, although there are so many things going on in the background? So if you look out at the operations going out behind the scenes in the kitchen side. So when we order a burger, right? So the customer service takes up the order, and the customer service agent, let's say, they make a request that I need this order, and then the kitchen processes it. And before even the processing can begin, there is someone who is ordering the raw materials to make this burger, right? And then there's some purchasing team who's arranging this raw material from the market or from warehouse, whatever it is. And then that raw material arrives. When the order is there, the kitchen, cuts the vegetables or heats up the buns and mixes it all together and makes a burger for you. So there can be so many scenarios which can be happening. Let's say, the raw material changes. The person who's trying to bring spices, let's hypothetically assume that the intensity of salt changes a little bit, right? Or let's say they are using a small microwave, right? It goes bad, and then they have to bring another microwave which is of a bigger size. So in that case, that means the bigger microwave will take less time to heat compared to the earlier smaller microwave. So what will happen? The kitchen will they will change the recipe, they will change the mechanism, because now they have a different thing, right? They have a bigger microwave. So they will reduce the heating time so that the overall burgers, how hot it is matches the previous version. So again, the person who's consuming doesn't feel so much difference, but there can be so many things. What if some item is not available in the market? Then the purchaser would have to go to another place. They might have to, let's say, the inventory they're storing, they might have to use it. So the burger won't be, as fresh as it would if they were using some other raw material. So similarly, that other things can happen in the kitchen side, right? I said the microwave example. The third example could be the customer service. Let's say the customer is waiting for their order to be delivered, but the customer service person is on a phone call, right? Or the person is busy. So instead of quickly returning the burger to the customer, the agent is taking 30 minutes or 1 hour to deliver it, right? And the customer keeps on waiting. So these are the different scenarios that can happen in the backend. However, they don't happen usually, and the customer leaves satisfied. And the reason why this happens is because there is a manager, there is someone at the supervising body who is taking care of all these different aspects. The manager is synchronizing these different operations so that the food gets delivered on time and the food is of the same taste and quality as it was in the recipe. What if the chef is absent, right? What if the, let's say, entire team in the kitchen is absent for some day? Does it mean there will be no burger? No, it's not like that. They will hire someone else temporarily, and they will provide that person a recipe, and the person will follow the recipe, and basically they will be able to create that burger, recreate that burger. Again, now we can see there is a lack, there's a thing here which can happen, but the manager with the help of recipe is able to overcome that. And the manager is also taking feedback from the customer. If the customer who orders the burger doesn't like it, they can give their feedback, they can raise a complaint. And the manager, what will they do? They will check why the problem is happening, and the manager will try to correct that problem. So in the case of machine learning, this is what the task of MLOps is. Now, this is the AI production. This is what happens with machine learning in the background, behind the scenes. When we are interacting with Facebook, when we are interacting with YouTube, when we are on Amazon, we are consuming something, we are getting a recommendation, we are opening the phone with our face. But in the background, a lot of things have happened, a lot of things keep happening. And some of them, as I said, are just like the previous example of McDonald's. In this case, there is a data engineer. So what data engineer does, the data engineer is bringing raw data. The data engineer is bringing raw data from different sources and then, ingesting it, transforming it, validating it for any, if there are missing values or if the quality is not right, and then preparing the data and storing it into a database. Then there is a data science team, machine learning team. What that team is doing is taking up that raw material or that raw data from the data engineer. And then that team is doing exploratory analysis on the statistical testing. They're training a model for their objective and then tuning that model, just like the chef will be, making the burger and, making it better, improving as per the recipe. And then the team is doing a model validation. They're checking that the model is giving the right results. It has, it follows the objective it is designed for. And then lastly, we have the application API, which could be the front end, the software development team. So the software team, the front end team will pick up that model, which the data science machine learning department has created, and they will deploy it for use. And when it is being deployed, what that means the customer is able to interact with it, with the model. The model is serving its purpose. It is giving some recommendation, or it is doing some, some anomaly detection or something like that. So these components will include deployment, serving, and also monitoring. If some issue happens, the customer service or the application, the front end will know, and the application will also keep logging about what are the major events which occur. So what MLOps is the strategy to harmonize these different departments. It is like the manager at McDonald's who keeps a track of everything and has recipes and if someone is not present, MLOps is, the manager is able to take a corrective action. So similarly, MLOps is able to take care of these different things, different aspects, and make sure that the entire cycle is running efficiently. Now, this is another view about the same cycle we saw in the previous slide. So the previous slide was a naive version, a simple version of the machine learning cycle. And this is from Google's paper about MLOps. And as you can see, this is basically the same elements which were in the previous slide, but they are structured in the real sense, in the how they will appear in the entire cycle. So usually, if we talk about machine learning in production, there are two departments. One is the local. So if I am a data scientist at a company, I would be building the machine learning models or AI in my own laptop, right? Or maybe on the cloud somewhere. And then there's a production server. So the production server is something which is the main, which interacts with the customer, which is where the actual product resides. So since machine learning is much more experimental in nature, so that's why it is usually separated from the production, which is much more, which requires much more robustness and much more, finality in it. So how would it begin? Like, if I am a data scientist, my first task would be getting the data, right? Now that data could be from different sources, and the data engineer has provided to me. And based upon that data, I would be training a model, right? We already know what a model is. So from that example about salary and experience. So this could be any model, an advanced model, right? And then the data scientist would be evaluating or testing the model, validating it. So these will be the steps I would be doing in my local host. So just as a fun fact, like most of the tutorials available out there, deep learning, machine learning, and CNN, computer vision related, for example, tutorials, forecasting, most of them pertains to only this blue area. But as you can see, there are so many other components as well involved in the cycle. So this first part is where I would begin. The data scientist and the data engineer would begin the data training and data cleaning. And then once it is ready, after analysis and reiteration, they will package their source code and the model and put it in a repository. And then there would be a step of the deployment step. So after in the deployment step, the package and the model would be sent to the production cycle, to the production, let's say, server. And what happens in the production server, things are automated. So now there's an automated pipeline. So what the data scientist was doing on the computer manually, once they have built a new, a final model, that goes into production. And then we have to automate those tasks for retraining. So in the retraining, what happens is that as the things change, let's say, let me give an example to explain that. Let's say you have a Face ID, right? So a Face ID is able to unlock our phone. So if you completely change your look, right? Nowadays, the models are very advanced, but previously what used to happen, model will not recognize you. So that you have to train the model again. You have to train the phone ID again, that this is my new look. And then the phone will retrain based upon that. And then it will learn to unlock with your new look after you have got a haircut and, changed your facial hair and, many more things. So that was, I'm talking about 5-6 years ago. Now the models are pretty advanced, which can do that automatically. So that is a simple example of retraining. So now what happens, it does that task automatically. So those automatic tasks, data scientist is not involved. So there's an algorithm which compares that if the new model, it has better metrics than the previous model, then it replaces the previous model with this new model, and the user is able to see an enhanced prediction services. There is also a performance monitoring, continuous performance monitoring view, which keeps on testing if the model is giving a right response or not. So this is the entire cycle of machine learning in production. And as you can see, there are several components in it. There are feature stores, there are triggers, there is a prediction service, there is monitoring service. There's so many things. And each step, each block in bigger organizations, let's say at Amazon. So at Amazon, for this yellow box data analysis, there would be a data analyst, right? At the feature store, there can be a data engineer looking after this aspect. In this step, the blue one, there can be a data scientist who takes care of this. In the pipeline deployment, there would be, let's say, a software engineer, full stack engineer perhaps, who looks after this block. So for each block, you can say there is a different job role, right? But in terms of MLOps, this is the entire purview or the field of play. So what can happen? Like, why are data scientists and data engineers, data professionals paid so much? Why is that so? So just to give you an example of what issues can happen. So this is a small example of issues that can happen in that cycle. So you can see there are so many failure points. As we look into the example of McDonald's, at the backend in the kitchen, what can happen? Similarly, in the AIS in the backend, there's so many things that can happen. The data can stop coming. There can be the production service or the server can go down, right? Or the model will not work at all. If there is no documentation, let's say I deployed a model and then I leave the company. The new data scientist who comes, he doesn't know where the code is, how it has been trained, because there's a lack of documentation. So again, if there has to be an upgrade or if there's a downtime, the new data scientist will not be able to do it properly. So everything which we discussed in the McDonald's example, so you can put the same analogy here. So many things can happen. So that's why we need a manager service. We need something that integrates and keeps a track of everything and synchronizes it all. So that's where MLOps come in. So there is an 80-20 rule of data science, which says that only about 20% of the project time is spent on model building and tuning. The rest goes into data collection, cleaning, preparation, deployment, which is true. So what that means is if you are working in a company and you have to work on a data science project, so 80% of the time you will be spending in cleaning up the data and checking your model and deploying it, trying to deploy it, and making it work. So this is a tweet from some data scientist, which she said that the story of enterprise machine learning, it took me 3 weeks to develop the model. It's been more than 11 months and it's still not deployed. So if you get an opportunity to do machine learning in production with an actual company, that will be an awesome experience, because not many data scientists can do that currently. I have been lucky to have that opportunity with actual products. So the AI that I have trained, I had the opportunity to train. They are right now running in some plant and helping in some actual operations in the US. So that's what you should target if you have trying to make a career move. So if you find an opportunity where you get to do machine learning in production, that will be an incredible experience. So there's a reason why this happens. Why so many projects do not make into production, because most of them are experimental in nature and they do not generate any business value. Now that's a separate topic for another discussion, but that is one big reason, because people are building models that do not solve any actual problems. So that's why most of the those projects do not come into fruition. So the concept of MLOps is fairly new. It was only in 2015. when Google released a paper called, and it called Hidden Technical Debt in Machine Learning System. And that paper talked about how little shortcuts or how little things that we do in machine learning in production, they can have a long impact on productivity, and they can have a lot of maintenance cost and those kind of things. So Google proposed that there should be something called an MLOps, a system which harmonizes, which manages the entire cycle, machine learning in production cycle. So to define it, MLOps is a set of practices for collaboration and communication between data scientists and operations professionals to manage the machine learning cycle in production. So it takes care of the machine learning, the development, and the operations phase. So it integrates all these three phases together. And if I talk in detail about what MLOps aspects are, so the first MLOps aspect is team and project management. That is the first utility. And it has these 10 steps, like these 10 things. They can be more or less, but I just took a comprehensive view. So the first one could be team collaboration. So let's say I am running a company. I have 4 different data scientists, right? I hired one from one city and 2 from another city, third one from another institute. And all of them have different tastes. One likes to do machine learning on TensorFlow, other one on PyTorch, the third one builds simple models on sklearns, and the other data scientists use R instead of Python, right? And let's say another person uses Tableau. So the manager who's an analyst skills, he or she likes to use Tableau to visualize the insights. So all of them have using different tools. There should be a singular point of contact through MLOps where they can talk in the same language, and that will help in team collaboration. The second point is version control. So just like the code, we have different versions. In MLOps 2, there will be different versions of not just the code, but also the data set, the model, and the data variables that you are getting. So you have to maintain multiple versions of so many things. Now, the third is storage and versioning of large data sets. You must have heard about GitHub, right? GitHub is used for version control and project management, and people store their codes there. But it has a limitation. It has a limitation of 100 MB data set size. It has a data set limitation. And also, if you're trying to add more repositories and more data sets, maybe there's a premium to it. There's a high cost to it. So that means if we are building a data science project and it takes, let's say, 1 terabyte of training data set, then GitHub alone will be insufficient to meet that requirement. Of course, there can be other tools as well, but it's not through GitHub. The fourth point is issue and progress tracking. So if let's say 4 data scientists are working on 4 different topics, 4 different projects, and then one of the data scientist projects is getting stuck or there are issues, then the other 3 can also track it other than the original data scientists. So that is basically issue tracking and progress tracking. Fifth is knowledge repository. So if, let's say, I'm working on some projects and I leave the company, everything is in my computer, right? So, and the new data scientist comes, he or she will have a hard time to first to understand the files in my system or the code on GitHub, and then to bring out look at the data set, what approach I applied, what algorithms I used. So with the help of MLOps, we should build up a knowledge repository in the organization, which has everything. It's like a library where new data scientists can come and read, or if my fellow data scientists like to read about my project, look at the data set, look at the code, they can get everything within seconds at their fingertips. So that's what knowledge repository is. Then continuous integration. So unlike DevOps, in MLOps, we continuously have not just new code, but also new data sets new versions of models, reverting back to the previous versions, retraining it. So there has to be a continuous integration with the production. That's what the sixth number is. The seventh point is shared plugins. So they can be tools which the team uses. So through MLOps, those tools should be available to the team if someone wants to use it. And then we have experiment management, which is looking at all the projects in the, or maybe through some authentication mechanism, what experiment to look at. And then there should be a deployment mechanism. So if I am using my computer, my laptop, and the other persons everyone is working on their laptop, and they want to deploy or send something to the production server quickly, they should be able to make an upgrade through the MLOps platform. And the 10th one is similar to the knowledge repository, which is the project documentation. So there are different tools for it, but it will be very useful if we can get the project documentation also in the platform itself. So this is about team and project management. The second challenging aspect is the data pipelines orchestration. So machine learning in production, they can be using real-time data from hundreds of sources. So if you are building an NLP model, let's say, it can be consuming data from the Twitter stream, from Facebook stream, from news website channels, so many different channels. So there should be some and it reaches a point where it becomes impossible to manually keep a track of what's going on. So there should be some automated way to do some sanity checks on the incoming data. So that is where MLOps should be able to contribute. So we can summarize that aspect in these 6 points, which is the raw data quality checks. If the data is missing or if the data is corrupted, it should be able to identify it, notify it. So and also handle it, take a corrective action if the data is missing. So to understand that example, let me give an example about the wearables. Smartwatch, I think everyone knows what a smartwatch is. So let's say the smartwatch is looking at your heartbeat to predict your health, right? So what if the model has only been trained on the adult's heartbeat? And if I take my smartwatch and give it to a child, and the children have a higher heartbeat than adults, right? So if the model is being trained in a bad way only on adults' data, and the data is changing, the model will predict that something is wrong. The adult is, not well, because it doesn't know that the data source has changed. A child is wearing that, watch. Similarly, if I remove that watch and, just keep it in my pocket, and let's assume that the model has been built in such a way, in a poorly developed way, it will think that the heartbeat has stopped. It can trigger an alarm that the person is, heartbeat is not running. So that will be an example of where the raw data the data stream has changed, and the system should be able to identify if there's a missing value, if it's a skewed data, if it's a corrupted data, or if there are outliers. So based upon that, they can be data change, there can be a corrective mechanism to it. The third aspect is reusable data cleaning scripts. So if everyone is cleaning the data in the same way and writing their own code, that is not a good strategy. That's not a good development strategy. There is a principle called DRY. DRY stands for don't repeat yourself. So what that means is that instead of everyone writing their own code to clean data, there can be scripts which everyone can share internally in the company, and they can trigger those scripts using MLOps to clean their raw data. So this would be more about data engineering side. So that data engineering team can reuse those scripts. Then we have automated feature creation, shared data stores, unified data assets insights. So again, not redoing the same task. If there are 3 different projects using Twitter data stream, tweets stream, then all 3 of those projects should not be, pulling up 3 different streams for Twitter. They can just have a single stream and all 3 can use it. So that is, again, one aspect of MLOps. And the last one is unified data assets insights. What that means is if the manager wants to have a view, there are 100 data sources, I want to know which ones are currently running live, which data I am getting, and which data has stopped coming. I should be quickly able to see that. I should be quickly able to view that information. There's something in the chat. Sir, from where can I get internship in data science domain? Okay, maybe I'll answer it later on. So that is the data pipelines orchestration part. So the MLOps should be able to simplify these things and make the team better and more efficient. The third is model management and metrics. So we know what model is. Model is nothing but intelligence stored in a file. And that model can have different versions. Let's say you have 2 different versions of a face recognition model. The first version is a very basic version. It fails when you get a haircut, when you remove your beard, it fails to identify you. And the second model of the same objective, that is able to identify you even if you, even without a hair, if you get a haircut, if you wear goggles, or if you, change your facial appearance, it's still able to identify you with some sort of, algorithm, some advanced mechanism. So that is what there will be 2 versions of the same, same project. So you should be able to track and manage those different model versions. And that is where MLOps should help. If I am doing it in my local host, like most of us do in our daily tasks, if we have to create something, we keep renaming it and copying, pasting it, which is not a good strategy. So there should be a systematic way to manage these different model versions. Second thing is model parameters and metrics. So this is basically the metadata that you used to train that model. That should also be visible. The third one would be model assets. So the data set and the scripts you used to train that model, that should have a record as well. So if another person is looking at that model and they want to retrain it, they should have quick access to that asset store. The fourth point would be model stage. So there are different stages of the model. If I am building it on my local host, I'm experimenting on it. It's not final. If the model is deployed into the app, it's in production state. If the model has got corrupted, if the model is no longer working, it's giving wrong recommendations because of some changes in the data set or input, then the model is considered stale and it should be replaced. It should be dead. Other things, if I want to compare the models, like what is the R square, what is the error metric between 2 models, which one is better, which one is bad, I should be able to quickly see that. The final point is model deployment and serving. So if I build a model in experimental stage and I quickly want to deploy it to production, there should be a mechanism to do so. So again, this is what MLOps should, these are the features MLOps should have. So the last thing I want to talk about MLOps aspects is the monitoring and automation part. So as the manager, we talked about in McDonald's, the manager was keeping getting feedback from the customer. The manager was doing quality checks and analyzing everything and keeping an eye on the entire system. Similarly, MLOps should be able to monitor these tasks, monitor the efficiency of the model and how it is retraining and how the workflows are running and things like that. Due to the so there are different steps here. I will not talk about each of them. So I will just, this is the last one, which is the interesting one about interoperability, which is if one model is being used and there's another model out there, which is also doing the same task, can I replace the second model and use the first model to perform both these tasks? Can the first model be serve the purpose of the second task? So that is interoperability. And if I identify that, I am cutting costs and saving money for the company. The fifth point was concept drift. So over time, let's say if the data set changes, I'm making a prediction, but the incoming data has changed. So the model that was trained on a data set is no longer working. That is called concept drift. So in that case, I have to retrain the model. So the benefits of MLOps gives faster time to market for ML projects. And the first benefit is productivity. So if we don't have MLOps, the things will be slow. There would be a lot more communication requirement. Everyone will be using their own setup and it'll be very difficult. So MLOps help in saving time and money by improving productivity by providing these features. Second benefit is repeatability. So what repeatability means is that if I have trained a model with, let's say, 95% efficiency, 95% R score, and the second person arrives in the company, second data scientist comes and I have left the company, they should be able to replicate, they should be able to repeat that efficiency with and get all the assets required to do so. So that is repeatability. Reliability. So CI/CD, that stands for continuous integration, continuous development, or continuous deployment practices. So what that means is if you are making a change in a production model, it should quickly be able to deploy. We should be able to deploy it, or it should quickly integrate in the production version, right? We should not be doing it manually, but it should automatically get integrated with the production side. And also it should do it in a way that the system does not fail. There can be big consequences of failure, right? So the model and the system should be reliable. Auditability. So if I want to go back and check all the versions of the models that I built and what were the efficiencies they had, there should be a very crystal clear pathway to do so. I should be able to audit the different versions of the input data and the outputs I got from the different experiments that were done to train that models. So we can demonstrate exactly how the model was built and where it was deployed. Data and model quality. So MLOps lets us enforce policies that guard against model bias and track changes to data statistical properties and model quality over time. So that is the what I call the concept drift. So again, if the data is changing, let's say as a kid, I was, let's say 12 years old, I got a smartwatch, right? And I keep using that smartwatch. And when I turn 50 years old, there will be changes in my heartbeat frequency. As a child, I would have more heartbeat, but as an adult, I would have, maybe the heartbeat will get slower. So what will happen in that case? The model should be able to recognize this fact and retrain itself. Else it will keep on giving false positives, right? So that is how your model should be flexible to the data over time. And MLOps should be able to identify and perform that retraining automatically. So building the MLOps, how to implement MLOps, so far we have talked about what MLOps is, what it should do, how it can benefit. Now we will talk quickly about how to implement MLOps. So there are different ways, different levels to do so. So depending upon the organization and requirements, you might decide to implement the complete MLOps infrastructure, or you might just like to have a few steps from it. And to do so, there are three options. The first option is building your own stack. This is a tedious option. This is like you are reinventing the wheel, but again, it can be, depending upon the requirement, it might be feasible in some scenarios. In this case, you use your tools and write the code from scratch to build up an MLOps platform. The second option is using fully managed services like Amazon SageMaker, Azure MLOps Suite, or Google Cloud's MLOps Suite. So these are three different methods of having a fully managed MLOps platform. The downside is that there are things that you cannot do. There is less customizability in this, and also there is a high cost. The third option is to implement MLOps is to use some open source framework and customize it. So this is the one I'm going to talk about today because it is free of cost and it has high potential because you can modify it accordingly. So the last one, it includes Airflow, Kubeflow, Neptune, MLFlow. So Airflow, I think it was made by Airbnb and then they open sourced it. Kubeflow is, I believe, from Google perhaps. And MLFlow, Neptune is from, I think, Netflix, not sure. So MLFlow is the one I'm going to talk about today. It's a complete MLOps stack, which you can customize and add a few scripts, and you can make it, integrate it implement it in your company. So MLOps is an open source platform to manage the machine learning lifecycle, including experimentation, reproducibility, deployment, and a central model registry. It has 4 different components. So MLFlow has 4 different features, and one of them is tracking, which is how you track experiments. Second is projects. In this projects, you can build automated workflows. The third is models. So models you can use to deploy models in production quickly from your host. And the fourth one is registry, which is how you add the metadata to the models and experiments in the repository. Benefit of MLFlow is that it is available through command line interface. You can program it through CLI. You can use a dashboard. You can use Python API. You can use Java. You can use R, or you can also use a REST API for it. You can find the complete documentation on this website. And to install it on your system, all you have to do is do a pip install MLFlow, and then you can instantiate the server by running this command called MLFlow server. Once you do so, MLFlow will begin in the local host. MLFlow has a lot of integrations with almost everything that is currently used in the data industry, beginning from TensorFlow, PyTorch to deployment, automation services like Docker, Kubernetes. It also has Conda support, R support, and of course, everything is this PyTorch is in Python. So yeah, so that means you don't have to write everything from scratch. Someone has already done it for you. You just have to integrate it. You should learn how to integrate it. That's all. In terms of setting it up in your organization, MLOps has it is flexible backend architecture. So if you want to set it up on a cloud, you can set it up on a cloud. If you want to change if you want to put the database of MLFlow in a different instance, on a different server, you can do that. In this scenario, you see 4 different components. So this is the local host which is used by the data science, data engineering team. This second is the remote host, which is the instance. Let's call it AWS instance, which has the tracking server. And then you can have the data sets or the assets in different, let's say, S3 buckets, or you can store the metadata into a PostgreSQL database. So in this case, you can see I have distributed the system into different levels. So that's one benefit of MLFlow. And this is just one example. There are different architectures that you can deploy. And this is a high-level view of how MLFlow will work. So let's say there are 2 data scientists, one cloud service, and their script. All these scripts and the members will interact with the tracking server, with the MLFlow platform. They will push their data sets, push the model there, pull the models, everything, and deploy, change the production state, things like that. And then MLFlow will take care of everything else, like the deployment. It will create an automated API for your models, which can be fetched. It has a very quick deployment time for setting up MLFlow and also to have the model ready in production. It also has a non-programming interface, which I'm going to show in a bit. It has a querying mechanism for models. So let's say you have 2000 models and you want to find out every model which had an efficiency greater than 95%. So you can run a query on it. It will return you all those models. This is an example of how to log, how to use your Python to interact with MLOps. So you can see the code here. This is the normal code from line 1 to 29. Like what is happening here is in line number 4, I am setting up, I'm telling my script which MLOps platform or where is my MLOps platforms. So I'm tracking it and setting it up. In line 8 and 9, I am setting up the experiment name or the project name, and let's call it project 1. In line 13, I am launching a new run or a new version of this project, right? Line 16 to 19, this is what machine learning does, like we are training a model. And line 22 shows, line 22, 23, how easy it is to log metrics. So in line 23, I am logging the hyperparameters of the model I trained in MLFlow. In the second step, this line 26, I am logging the metric of accuracy, which is the model testing score. In line 29, I am logging the model itself. So that file we talked about in the machine learning example, I'm sending it over to the MLFlow platform for production or whatever stage it is. So this is how easy it is to implement or to use MLFlow-based MLOps infrastructure. You can also log your data sets and artifacts using similar code, mlflow.log artifact. So that way, so this script can be running on your local host while the MLFlow is deployed on another, on cloud. And you can quickly log in your data sets, your assets, and they will start appearing. So this is the MLFlow dashboard. So once you start the MLFlow server, you can, in the cloud, you can go to that link it provides where the server is running. And you can see on the left side, it shows me what projects are there, and when I click on the project, it shows different versions of the model which were built. And it is also showing the name of user, name of the data professional, data team member who uploaded this asset or, this file. Oops. And on the right side, you see the different metrics that we logged in the previous step. So this is how it keeps a track. So you can quickly see what are the R scores, what are the algorithms, what are the different types of models I used in this project. Similarly, you can also create some sort of technical documentation in the model. So you see a little bit above there, about this project, what it does, its project ID. So you're adding notes in it. So this is how, so another person can join in who has access to these projects. Another team member can log into it, and they will also see these projects, these asset files, and they can quickly download it and run it. Now, the most interesting feature I found in MLFlow is this. So once I log the model from my code, MLFlow automatically creates the serving architecture on the right side. So this is a code which MLFlow generates for every model that you log to it. So let's say I built a model and I uploaded it. The second data scientist can log into this MLFlow, and she or he can simply copy this part, this right part, and start using the model in their application, start testing it. Similarly, the UI team or the front-end team can also use this code without worrying about how the model was created or how to call it, which library to use. The user doesn't have to worry about that. They can simply copy this code, which remains same, and start making predictions from the model, right? And these are the artifacts on the left side. You can see for each project. So if I quickly want to see what was the data set used to train it, I can get it from here. So to create automatic pipelines, you can create MLFlow pipelines by setting up your Python code in a way which MLFlow has described. You can read about it in the MLFlow documentation. And then you can give this command, MLFlow run. So let's say you have a pipeline of pulling some data. It can be stored on GitHub. And then you can call that pipeline. It can be stored on GitHub or anywhere, and you can run this command and it will execute the entire code. So this is what the project pipeline, automated pipeline looks like. So we saw like MLOps, how beneficial and how useful it is. And the reason I mentioned MLFlow is because it is open source. It has a large community. It also has a managed version. So this was the free version that we saw. There are also some commercial version by companies like Databricks, which has additional features. Now, of course, you can also write your own features, build it yourself. But if you want to outsource that work, there's already something out there. It has a large number of inbuilt integrations that can be used, as we saw. It has a flexible architecture for storage. So depending upon the resources and requirements you have, you can store the data on however you want it, on the cloud or on your local host or your in-premise server. There are multiple modes for deployment and serving. So the models can be served through a API, or there's a code for it. And you can also deploy it very easily from your local host. There is a versioning, documentation, assets storage features. You can orchestrate pipelines like retraining through the MLFlow projects module. You can also make a knowledge and feature repository on MLFlow by adding notes, interactive notes, and and text in it. And also, there's so many features in MLFlow, like monitoring. We saw in the dashboard, there were different metrics for monitoring. There is logging. They can be workflows. You can plot the metrics in the dashboard itself, and much more. So these are the benefits of MLFlow and MLOps through MLFlow. Since we are short of time, so I will, that's why I a little bit hurried in the last few slides, but thankfully we finished within the 1 hour that we had. So any questions so far? Any doubts? So someone asked about where can I get internship in data science domain? I'm not the right person to answer that question, but you can go to Google and search for internships online. And there are several projects on Kaggle where you can try getting knowledge through that, and trying for internship through those projects. Any other questions?
Guys, any questions would you like to ask?
Okay, so would it be correct to say that MLOps take care of the SOPs for a company? Yeah, it would be correct to say. MLOps is a framework that, like I said, you can make it to use. You can define your SOPs in the MLOps and store them over there, have the programs for it. You can have different pipelines that follow those SOPs, and they should be triggered by they should be used by the data science team. So yes, that will be correct to say. What level of MLOps knowledge is required for a data scientist? Okay, that's a good question. So if you are purely working in data as a data scientist, working remotely on your system, let's say, you are not involved in the production cycle. So in that case, you should be able to interact with the company's MLOps platform. You should be able to know how to send your code to how to deploy your model, how to pull up the data sets from your repository. So that should be the basic level of knowledge a data scientist should have. But if you're working in a smaller company like I do, where the data scientist, or it's like wearing multiple roles, or you are the one implementing MLOps, then in that case, the presentation that we did today was a good first step towards that knowledge. It gave a very comprehensive view about MLOps. Aditya Rai, sir, my question, when anyone from CSE branch, in which domain project needs to work to get a job as a data scientist? So to get a job as a data scientist, let me tell you something very interesting. About my background, right? So one job I did was I used to work in a factory. That was not a computer science work. I used to work in a factory. I was a manager there. So if you know about how factory works, it's production cycle, right? It's not computer science or programming or coding. But I did that. I did that because I saw some problems. I saw some opportunities in the factory. So to answer your question about how to, but now you can see I am a software engineer now, I'm a data scientist now, because I have that functional knowledge about the factory or production manufacturing side. And computer science, data science is just a tool to solve the problems of that industry. So to get a job as a data scientist, I am assuming you already know about computer science, right? So now what you need to do is define your functional area. Where do you like, what is your interest? Do you like retail? Do you like healthcare? Do you like production? So what is the industry you want to get into? And start learning about it. So now you have two things. Then you will have the data science or computer science skills. And then you will have, and the second thing you will have is your functional knowledge. And if you combine that, then it will be very easy for you to get a job as a data scientist. And like which domain you like, that is perfectly your, completely your choice. Some people like retail, some like manufacturing, some like engineering. So I think that answers your question. Can you mention any live projects you are working on? So one project which I'm really proud of, which I'm working on is, it's called COVID-19 early warning system, COVID-19 surveillance system. So that is the project that I led. And we are providing services to 45 sites in the US. What that project does, it analyzes the wastewater which is coming out from the houses and communities, neighborhoods. We analyze that in the lab, and based upon the insights and the different data sources that we have from Facebook, from Google data set, from GPS data. So based upon these different data points, we are able to predict how the COVID-19 trend is going to look like in the next couple of weeks in the US. What is the minimum number of infected people in a neighborhood or in a community? So that is one project which is currently going on, live project I'm working on. So what would be the difference in the scope of MLOps be with respect to business analytics? Like how extensive is this is the next question, like how extensive is the demand in the industry compared to an analytics role? Okay. So the field, the industry of data science is now moving towards automation. So instead of writing my own algorithm, applying algorithm to understand data, build a model, that task is being taken care of through things like AutoML, right? Where I just feed the data and tell it what to do, and the system automatically builds a model and give it to me, right? So that means there is less requirement of data science skills or analytics skills, business analytics skills, sorry. But having said that, MLOps is something which is new, because even if you have that automated system, you need to have a manager. You need to have someone who manages that system, manages the incoming data, manages the output. So this is something which is very hot, and it is something which is growing, while the other field about core data science or core algorithm could be going downwards. So that's what I like to say about the demand in the industry compared to an analytics role. So to switch to MLOps, you need to have a basic data science knowledge, good knowledge about how programming and applications work in production, and also some managerial skills. Like for instance, I have a Lean Six Sigma black belt background. So that really helps me in whatever I do now. That's not related to computer science. That's not related to data science, kind of related to, but that philosophy helps me in managing the projects or implementing these types of things. Is there any, so the next question is there any predefined framework of MLOps available to get started and get some hands-on? Yeah, so like I just described, MLFlow, that is a framework that is open source. You can install it on your system quickly. Just pip install MLFlow. You can read about the documentation, how that works. I think that'll be a good framework to start with. If you want to be a little more non-technical, if you don't want to do a lot of programming, you can try AWS SageMaker. I'm not sure if that is free. So that is a complete MLOps framework. You can use that. Next question is customer segmentation using RFM and K-means clustering. I don't know how to answer that. I don't know what that question is. Shreyash Deshmukh, sir, from where can I get internship in data science domain? You can search on Google about the internships. All right, I think that was the last question. So thank you so much for your questions and for attending this. And if you have any more questions, you can reach out to me on LinkedIn. You can connect with me on LinkedIn and I could be able to guide over there.
Guys, any more questions would you like to ask? I believe no questions. Thank you so much, Nabil, for taking our time for us and enlightening our student with such an extensive knowledge session. Thank you so much for giving us time.
Thank you, Misbah. Thank you for inviting me. Thank you to your team for arranging this. It was my pleasure.
Thank you so much. We are happy to have you.
All right.
So we'll conclude this session.
All right. Take care, guys. Bye.